When moisture gets trapped inside high-voltage electrical equipment, the result is often a sudden, catastrophic, and explosive failure. Paper insulation with just 1.5% moisture ages 10 times faster than dry paper, making water the primary driver of equipment decay. To neutralize this threat, you need a high-capacity filter machine, a 5,000-volt insulation tester, tarpaulins, and spirit-type thermometers. Correctly executing the hot oil filtration process extracts this water and halts the rapid insulation decay, preventing a total and premature asset failure. We begin with the physical setup. On a standard power transformer, identify the cooling radiators and upper high-voltage bushings where testing will occur. For fresh units, connect the filter's inlet to the top valve and outlet to the bottom to create a top-down circulation loop. For older, sludged units, reverse this connection for the first 24 hours to flush contaminants from the bottom. Close the radiator valves to retain the heat you are about to apply, but ensure at least one valve remains open to allow for thermal expansion. Wrap the main tank in tarpaulins to trap heat, but leave all test terminals and thermometer pockets exposed for monitoring. Use only spirit-type thermometers in the pockets. Mercury thermometers are banned, as a single break will chemically and electrically ruin the core. These setup steps act as physical safeguards against pressure and contamination before the circulation begins. Start the filter machine and confirm the vacuum is pulling a minimum of 710 millimeters of mercury. Maintain the oil at 70 degrees Celsius. Do not exceed 80 degrees, or the oil will carbonize and cause a sharp increase in acidity. Track your insulation resistance, or IR, using a 5,000-volt megger. Log your data every 4 hours, then switch to 2-hour intervals once the oil reaches 70 degrees. Expect an initial drop in IR values. Heat actively pulls trapped moisture out of the paper and into the oil, lowering the resistance. As the vacuum extracts this moisture, IR values will stabilize and steadily climb into a high plateau. Following the curve rather than reacting to the initial drop confirms that the solid insulation is actually drying out. Continue circulation until your logs show a rising IR tendency across 6 consecutive readings. If the filter plant loses power or trips, close the valves immediately to prevent an oil overflow. Once the IR readings stabilize, draw a hot oil sample to perform a breakdown voltage or BDV test. The hot oil sample must withstand at least 60 kilovolts RMS before breakdown occurs to meet the safety standard. Hitting the 60 kilovolt BDV mark and the steady IR plateau confirms the internal environment is dry, concluding the active dehydration phase. Turn off the heaters and allow the transformer to cool completely to ambient temperature. As the oil cools, you will see the IR values naturally peak and lock in their final position. Draw a final ambient oil sample. It must pass a 50 kilovolt dielectric test across a 2.5 millimeter gap. This side-by-side comparison shows the result. The cloudy, moisture-laden oil on the left has been restored to the crystal clear state on the right. Passing these final ambient metrics confirms the asset is dehydrated, fully insulated, and safe for the high-voltage grid.